Okay, again we're doing math 115 on the rain data. Um, I left off where it was for the bin and the intervals and all this other wonderful stuff here. Okay, so for the bin and the intervals, what the professor said is we basically can decide how many bins we want. And you got to think of bins as, say, like files. Maybe you have a folder that might say rain data, but in that folder, when you click on it, you might make 6 more folders that you're going to put a certain amount of data in. Each of those folders is going to have data for specific amounts of things, but you have to equally distribute it, and that's where we're coming up with these bins. These bins are basically like these folders that are going to hold that information, and you're dividing it by this exact same number, and that's where the intervals are, the exact same spacing. Okay, let's see if I can explain this. So I chose to do 6 because you're using the range, and the range for this is 35.49, which if I were to round it off, it's either I'm going to go by to 35 or 36. I chose to just kind of round it off to 36. And so what divided by what would be close to 36? Well, 6 divided by 6 would be close to 36, so I chose 6. Other people chose 8 bins. Other people chose, 9 or 10. But let's just, for example, if I had chosen to do the 6, like I choose to do the 6 bins, and I were to take that range and I were to divide it by the number, right, the number of bins that I chose, which is 6, I would get a number like that, 5.915. So I was going to do my intervals in the exact number that I could divide it by. But if I did that, it was going to get really messy, and the professor explained to me why that wouldn't be a good idea. Okay, so let's just say I started with the minimum rainfall. Where's the minimum? The minimum rainfall was 1.71. Let's just say I started, my file was going to be 1.71. Oh, well, let me go with the equal sign first. And I'll just click that. The 1.71, we'll just start off there. Well, in this one, that would be my minimum that would be able to go into my folder. And then if I did that interval where I said this, the 1.71 plus whatever my interval is, it would be 7.625. And then the next minimum for my bin number 2 would have to be this number plus 0.01, because it can't, it would have to be at least 1 point more than the last one, right? It couldn't be the exact same number. Okay, or 0.011, sorry, in this case, because it's not rounded. If I rounded it, it would have been fine, but I didn't round it. Actually, let me just go ahead and do that. Why don't I just round it down? Round that down. Okay, so if I did this, equals this number plus 0.01, I'll get 7.64. But you see how then I would have to take that number, this number, plus that interval, if I had done that messy interval, in other words. Oh, I went too far. This one here. Oh, see, I'm still going. Plus just that one equals. So I'd be getting all these rough digits. So the professor suggested, instead of doing that I would just start with a number that would kind of start making these numbers look a little bit more even. He said your file can start with something that's less than the minimum, and it could end at something that's more than the maximum. So it's just what you're just dividing these files equally, and so he suggested that I go with something that would be better. So he said something with 6.99, like let the ending number be 6.99, so that this number could start off with the 6.99 plus 0.01, which would equal 7. So what would this number be? Well, this number has to be minusing that interval. Okay, so because I'm starting with 1.5 is where he said to start. If I were to just do something on the side so you can see, well, 6.99, because these are the numbers he chose. Now you can just make up your own numbers or however you want to break it up. That was going to equal 5.49, and that's how we got an interval of 5.49. So now all of the spaces between the minimum and maximum in each bin has to be a space of 5.49. Okay, so we got the 1.5 plus the 5. Well, let me take that away just so you can see it. Right, we got the equal. We take the 1.5 plus the interval, and we've got 6.99. And then we've got again the 6.99 plus the 0.01 to make it 1 point higher, and we got 7. And then this one is going to be the 7 plus the interval. Okay. Again, he said we should be able to highlight. So let's highlight these two, and then when we get the black, we should be able to just bring it down, and it should do the +1. So it added the +1 for each, but it did not add. Oh, you know what? Let me erase that. Okay, this one here, instead of pushing that button for the 5.49, you actually type in the 5.49. There we go. And now you can copy it, and it will do that for both. Ugh, why did that happen? Alright, let's do this again. Let's highlight those two, get the black on, and we have to go down to the 6 bins because that's how many bins I chose. Okay, there we go. So we've got a minimum in the first bin, any rainfall that was from 1.5 to 6.99. In the second file, we're going to put 7 to 12.49 and on and on and on. Okay, and each of those have a space of 5.49, which is the interval that we chose. Okay, so as far as frequency goes, frequency for bin 1, we have to find all the rainfall that was from 1.5 to 6.99. So we are going to go look up here because they're in order. So 1.5, we don't have a 1.5, but 1.71 is in that range. Oh, that didn't work. See, it's hard doing this with one hand. So 1.71 to 6.99 is what we said. So 6.39, set 9.08 would be too high. So those are all highlighted. We would come down, we'd look at the count. Count is 6. So the frequency for the file 1, for everything that falls from 1.5 to 6.99 is 6. Okay, then we go back. What is 7 to 12.49? Well, 7. Again, we don't have a 7, but the closest is this here. Is that 9? 7 point to 12.49, I believe it said. So the 12.45 would be the closest. 12.6 would go over. Let me make sure I had the numbers right. 12.49, yeah. Okay, so what is the count? Count is 23. Okay. I'll do one more just so we can see. The 12.50 to 1799. 12.5 to 1799. $12.5. Oh, it'll be this one here, the 12.6. Right, to 1799. Gotta keep going down. Okay, 1799. That's 1786 would come the closest. The count would be 50. So we put the 50. Okay, and I'm sure you'll be able to figure out how to do the others. Look for that which falls into the range of 18 to 23.49. I've already got it here, so we know it's 32 because I've already done exactly how I showed you. Just keep repeating the same thing. And the last one was really easy because the only thing that fell from 29 to 34.49 was this very last one. So there was only one, which is 37.2 that fell in that range. So we put a 1 there. Oh shucks, this keeps glitching. Okay, cumulative frequency. Cumulative means all together, added up together, right? And so we start with the very first one, and then the second one, it's this plus this. And we add that together. And let's see, does that work if we just bring it down? Yep, it does. One of the main things that we need to know is, does this equal 120? Like when we add all of these things together, is it going to end? So when we do this cumulative frequency, we find out when we add all these numbers, yes, it does. It equals 120. Okay. Now the way we find the relative frequency is to find the percentage of whatever the frequency is. So we're going to take the frequency, we're going to put an equal sign, we're going to get that frequency right there. Now we have to divide it by whatever the count, the whole count is, which the whole count is 120. We can check that by looking again, that n is the whole count, it's 120. Okay, so we have to divide that number by, I'm just going to choose that 120 right there just because it's easy. And this number, we have to take that and divide that by 120. Okay, so for bin 3, how many total? We have 50. And we have to, the frequency is 50, we divide that by 120. Then bin 4 has 32. And we divide that by the 120. And then bin 5 has 8 in the frequency. We have 8 that fall in that range, and divide that by 120. And then the last one, there was only 1, and you have to divide that by 120. And this is what we've got. Okay, now by the time we do this cumulative relative frequency, we're just checking everything. Everything needs to be able to equal 1. When I add all of these together, this last number should equal 1. If it's not, we did something wrong. Okay, so this, we're taking that first number. For this one, we're taking this, and we're adding that first number, right? Okay, so then let's see if we can drag it and see if we come to the 1, and we do. So we knew that we did everything right. So basically that's how we do these bins and intervals. I would erase all of this because this is just a duplicate of what I already did, but just something basically for us to remember, how we can do it. So hope this helps. Let me know if you have any questions.